In the previous video, I've introduced you to the Hello World program and you were able to learn the basics of Java. I've mentioned the word keywords, and today I'll be discussing what the 8 primitive data types are and how they're represented with variables. Now, it's first best to explain what a variable is. A Java variable is a unit of storage that contains a data value which is always represented by a data type. It's like a package at your front door, and the box is labeled in such a way that you have a general idea of what's inside. This box you can see here is called cool shoes, and obviously you can deduce that there must be shoes inside. It wouldn't make sense if you saw a book inside. Anyways, inside the package it's the new Glide 2000s, or the Hover X, or any other particular shoe that you order. And this scenario is the same with a variable. You always know what the data type of the variable is, and the data value contained that corresponds to that data type. There are numerous forms of data types, but I'll first teach the 8 primitive data types, which are byte, short, int, long, float, double, char, and boolean. It may seem like a lot, but I'll explain it with 4 groups of data types: integers, decimals, characters, and true-false. With all that, in this video I'll just be introducing to you integers. Okay, let's get started. Have your Genie text editor open on the left and your command prompt or terminal window open on the right. And the first thing you gotta do is create a new Java file. So let's save this document and rename it. So press here, go to File, then go to Save As, and I'm gonna call this file datatypes.java. Do not forget the .java part because it is important in indicating this document as Java file. Remember to save this in your Genie Java projects folder just for organization. Press Save right here to save what you just done. To introduce our Java document, type public class data types and then 2 curly braces. Also, type your main method: public static void main parentheses string args 2 square brackets end parentheses, and then type 2 curly braces. To start off with our integers, within your main method, which is remember what your computer reads first, type int. And notice that the word int is highlighted. This means that it has a specific predetermined function. Then type anything you want to create a variable. I'll just call it x. And like an algebra class, x is our variable. But if for some reason algebra sends shivers down your spine, we can call a variable Fred, we can call it Bob, we can call it this is an integer variable. You can call it anything. Anything except keywords like int and public because they already have a predetermined function encoded in the Java language. Regardless, I'm just still going to call it x. End it with a semicolon to end the statement. And so in summary, since we typed int before x, we define x to be an int variable or a variable that is declared as an integer. To represent x as an integer or initialize it as an integer, on the next line type x equals 5, end it with a semicolon to end that statement. And so this equal sign makes the variable x store the integer 5. And so to see if x really is 5, let's type system.out.println x. Remember to save the file to update the Java code you just typed. On Windows, a keyboard shortcut is Ctrl+S, and on Mac it is Command+S. After you've saved your file, go to your terminal window on the right, and we want to locate where our Java file is located within our computer. In my case, I have to first change my directory to my desktop, so I'm going to type cd space desktop. I'm going to change my directory again to Genie Java Project, so I'm going to type cd space GA, and I'm just going to press the tab key so that the command prompt autofills for me. Press enter, and to compile our code, type javac datatypes.java. Press enter again, and to execute, type java space datatypes. Now before I execute the code, what do you think is going to be printed out? Now the thing is, we aren't going to see the character x be outputted. Instead, it's going to print out 5 because x is a variable and it stores the integer 5. Among integers, int is the most commonly used primitive data type to represent integers, but there are 3 other primitive data types that can also represent integers, and this is just because of storage space. Any data type takes up space in a Java program, and an int has a storage of 32 bits, meaning that an int variable can store an integer value from -2 to the 31 to 2 to the 31 minus 1, and this produces a range of values that equates to 2 to the 32. In the event that you want to use integer primitive data types with less storage, you can use byte, which is 8 bits, or short, which is 16 bits. And if you want to store a very large integer, you can use long, which is 64 bits. And just to show you guys the examples, I'm going to type byte A equals 3 and with a semicolon. Notice that the word byte is highlighted because it is a primitive data type. We can actually declare and initialize in the same line, as you can see I did here. So basically we declared A to be a byte that is initialized to be the integer 3. For the other examples, I'm going to type short B equals 45. On the next line, long C equals, I'm just going to make a really big number. And then I'm going to type L before I type the semicolon. Now here's where things get a little complicated. Because why is there a letter L after the long number? Is it because the Java language wants to make our lives harder? And the short answer is yes. For a longer number, we have to type the character L, which only makes a statement even longer than it already is. But the thing is, if you don't type the L, the computer will interpret this as an int. And this large number is outside the storage space of an int. Remember that int could store a value between negative 2 to the 32 and 2 to the 32 minus 1. And this number is just outside that range. If we try deleting the L right here, and let's do it right here, we could get an error. Also, just test it out. Type system.out.println C to see if this long number even gets printed out. Go to our command prompt, and as a keyboard shortcut, you can press your up key to retrace what you just typed in your command prompt. Press up twice to type javac datatypes.java, and if you compile the code, you can see that we get an error that says integer number too large. Now going back, if we change this long number to, let's say, 5,647, and you want to print out this number, let's compile the code and execute the code, you don't get an error because 5,647 is within the range of an int range. Now remember, the computer will always first interpret this number as an int. Only if you type the letter L will the number be interpreted as long. But why are there so many data types? It is simply because as computers got more and more advanced, there was just space allocated for larger types of data. Let's look at how the data types are related because they're all integers. Since the range of possible values for byte is within the range of possible values for a short, any byte can be stored in a short, and the same is true for the relationship between short and int and long. This also means that byte can be stored in an int and a short can be stored in a long. With an analogy, think of it like Russian dolls, where byte is the smallest doll. And in this case, it is the green doll, and due to its size, it fits in any doll that is slightly bigger than itself. So the green doll fits into this yellow doll, and similarly, a short can hold a byte. And then, this yellow doll fits into this larger blue doll. An int can store a short, as well as a byte. As you can see, the green doll fits into the yellow doll, which fits into the blue doll, which means that the blue doll can also hold the green doll. Finally, the largest doll of them all is the orange doll, representing long, which can hold any data type. Now as you can see, you can fit a short and a long, or a smaller yellow doll into a bigger orange doll, but you can't fit a long into a short because the yellow doll is simply too small to hold the orange doll. This can be easily tested with addition. For instance, we want to compute a sum, so we can type int sum. Since sum is an int type, we can only add data types that int can hold, which include int itself, short, and byte. So I'm going to type sum equals a plus b plus x and end it with a semicolon. A represents a byte, b represents a short, and x represents an int. The addition signs here simply add together the number each variable represents. Since any int can hold a short and a byte, this is all okay. To test it out, we can type system.out.println sum. And as you can see here, if we compile and execute our code, we get the correct sum of 53. Remember, we cannot do addition for ints with a variable that is a data type of long because an int can't hold a long. So if we go back and add c to the equation, we're just going to get an error. So let's try it out. Go to your command prompt, compile the code, and as you can see, we get an incompatible types error, meaning that in Java language, you can't store a long into an int. So that was a lot of information on just integers. We can get good at this stuff if you practice, because this type of stuff is fundamental to understanding how the Java language operates. In the next video, I'll be teaching you the other 4 primitive data types and how to represent those with variables.